Quick revision video on excess and limiting reagents. So we'll start with the essentials. You can't tell what the limiting and excess reagents are from masses. You need to calculate the moles first. Beware mole ratios. So the examples I've got coming up have got different mole ratios in, so we can explore that. The limiting reagent limits the maximum or theoretical amount of product it can form. The limiting reagent is the reactant that's totally used up in a reaction. The excess reagent will have some left over after the reaction. So here's the first example. This is probably the easiest of the three that I've got. So if you wanted to have a go at that now, pause the video and then play on when you're ready for the answer. So like I said on the essentials slide, the first thing you've got to do is calculate how many moles you've got to start with. You can't tell which is limiting and which is excess from the masses. So it's just mass over MR. So the initial moles of methanoic acid is that many, and the initial moles of the alcohol, propan-1-ol, is that many. So now we've done that, if we look at this one here, so the methanoic acid, you can see we've got 0.0652 moles of that. Well, obviously from the mole ratio, you're going to need that many moles of propan-1-ol to react. So basically, there's not enough moles of propan-1-ol, so the methanoic acid won't all react. It's therefore in excess. So we've established the excess reactant is that one, so that's obviously the limiting one. So once you've done that, you can work out how many moles of each will actually react. So moles that react, well, all of them will react because there's enough of the other one, but only that many moles of the 0.0652 will react. So there's going to be some left of this. So now we've done that, we can go into the calculation. So what's the maximum theoretical mass that we could get from this reaction? So the moles of ester, so this chemical here that could form, would be 0.05 from the 1-to-1 ratio, and we just need to turn that into grams now by multiplying by the MR, and so it's 4.4 grams. So the second one's a little bit trickier, so again, if you want to do the same, pause the video, have a go, and then play on when you're ready. So first thing is initial moles, so mass over MR gives us these many moles of the two chemicals. If we just think about it, we've got that many moles of magnesium, we'd need half of that moles of TiCl4, so we've definitely got enough of that. So if we do it the other way around, that many moles of TiCl4 is going to need 10.53 moles of magnesium. Well, we've got nowhere near that. So there's not enough moles of magnesium, the TiCl4 won't all react, so it's in excess. So excess reagent is established, and so is the limiting. So moles that react now, well, obviously all 4.115 moles of magnesium will react, but in terms of the TiCl4, half of 4.115, it's a 2-to-1 ratio, so only 2.058 moles of the 5.266 will actually react. So in terms of how much titanium can we make, well, we can get 2.058 moles of titanium. So I'm using this ratio here. That's a nice 1-to-1 ratio. You could have done it on the 2-to-1, so 4.115, half that, you're still going to get that number there. So that many moles of titanium can form, and let's just turn that into grams now by multiplying by the MR of titanium. So the answer was 98.6 grams. Final one, so pause and then play on when you're ready. So initial moles, mass over MR, so we've got that many moles of each chemical. So if we think about this one first, we're going to need 3 times this number moles of hydrogen. Well, we've definitely got that. What about the other way? So those 250 moles of hydrogen are going to need 1/3 of that in terms of nitrogen moles to react. Well, we haven't got that. So there's not enough moles of nitrogen, so the hydrogen won't all react. It's therefore the excess reagent. So nitrogen's limiting, So the moles that will react, all 35.7 of the nitrogen, but only 3 times that of the 250. So it'll be 107.1 moles react. So that's 3 times 35.7. So now we've established that. 71.4 moles of ammonia can form. So if 35.7 moles of that react, twice as many moles of ammonia will form. I could have done it on this number here. It's a little bit trickier, but you're still going to get the same answer. So if 107.1 moles of hydrogen react, then 2/3 of that of ammonia will form, which is still that number there. So now we've done that. Mass equals moles times MR. So we get 1214 grams.